Hello, students. So this is the manufacturing system, week 7. So I'm going to start this week's module. So we have two modules. So first module is 20 minutes may take. So the topic is separating processes. So we are studying about the secondary manufacturing processes. So secondary manufacturing process consists of first one was casting and molding, and forming and processing and separating process. So first three processes are making a product in the secondary process, and then 4 to 6, such as conditioning, assembling, finishing, are the post manufacturing process. So first three are important. So I'm going to finish the separating processes first, and then second module will teach about the conditioning process. So we have four objectives. So first one is distinguish between process of machining and say searing. So those are two types of separating process. So I will let you know the term, the machining and shearing, and list three essential elements of separating processes, and then name six basic machines that have been developed to separate machines, and explain how those separating machines operate. So those are key words. So if you have a chance to read the textbook, so there are lots of the separating processes, but this module I will only highlight some key elements from the textbook. So I'm not going to teach everything because some are a little bit so much detail. So yep. So let's enjoy this week's module. So I'm going to start with this question. So have you thought about this question? How to make metal chess pieces? So how people make like these metal pieces? So these are a little bit different. So in the casting or molding and forming process, they made a mold and then they press and then create solidify the resources. But these looks a little bit different. So it may be have the original, I mean the primary primary product was like this cylinder, but they changed like this form. So that is an example of separating processes. So before I start, I wanna share this video. This is talking about CNC lather. So the CNC lather is one of the important machine in the manufacturing processes because lots of the cylinder type products are made of this CNC lather. So let's look at this video together. Um, yep. Let's go back just a little bit back. So yes. So this was the primary product of this manufacturing. So we are using this cylinder shaped material. So to make a chest shape. So first step is do you see that this blade this blade? So this is cutting this material, right? So this material is attached to the machine called the chuck. The chuck is rotating while holding this material. Then this blade is cutting the material. The centerpiece of the material is rotating. Yep. So this is the small particles. So these are small particle from this original material that called the chips. So chips are important because these blade taking off these chips. So while taking off these chips, so the material is made of in the shapes of the final product. Because the jaw chucks, so 3 jaw chucks, they hold this machine, this material. Yep. Also, this blade can cut the side face. This also make these shapes. Yep, this is rotating. There are basically two types of lather. First one is manual. That means people operate all of this process. But this is a CNC lather. That means the computer, numerical computer, numerically controlled. Also can make hole by cutting inside. Mm-hmm. Finally, this cuts these products using, I think this water jet machine that cuts using the water, very high pressure water. And then the finishing the product. Yep, this is the final product. So this video answers this question. So how to make metal chess pieces? So using the lather. All right. So this is an example of separating processes. So yep. So separating process means converting a material to size and shapes by removing excess material through the cutting or shearing. And the term, the cutting and shearing, can be used in this in the manufacturing. The cutting is shearing, and then filling off is machining. So this is machining. So shearing means a process that use force applied to the opposite edge to fracture excess material always away from the workpiece. So this cutting this piece. The machining is taking off, like peeling off of the surface of material by changing the size and shapes of material by removing excess material in the form of chips or small particles. So this is the example. So this is the blade, and then the pushing the blade or this material is moving that cuts like this piece. It's called chips. So yeah, this is the two types of separating processes in manufacturing: shearing and machining. And there are three basic elements of separating. So I brought this example from this website. This is an example of shaping machine. So in this example, so there should be a tool or other cutting element. So I mentioned the blade. That is this tool. We call it tool. So this part. Do you see like this machine? Let me. Can you stop? Yep. This. Yeah. Anyway, the blade type. This one. This is called tool or cutting element. And then it should have also the motion. They have to motion to cut the element to cut the material. Like this example, there's a back and forth a movement. They call reciprocal movement. And then third one is work or tool is given support. So this example, the material supported by these devices. Also, the tool is supported by this machine. So all work or tool is given support. So that's three elements. First one is tool to cut the material, and the second one is motion, and then third one is work or tool is given support. So support should be exist. So and then let's look at the three elements. So first one is tool or cutting elements. So there are a variety of tools. So the tool is based on the hardness of property of material. So if we want to cut a certain material, the tool should be more harder than the material. So that's the one principle. So only you can cut a softer material than the tool. So example is we use diamond to cut glass. So there's a most hardness scale. So we follow this rule. So the diamond can cut everything, but we don't make everything every tool using diamond because diamond is expensive. And then corundum or topaz, the certain layer of the most hardness scale. So for example, this is another example. So this is masonry drill bits that is made of the corundum. So that's we called carbon carbide. So carbide is masonry drill bit is made of carbide. So this is also higher on the most hardness scale. And then second one is cutting tool design. So when you design a cutting tool, there should be certain principles. So first one is avoid shape point. So we should have certain level of shape points that at the end, but this rule, because if we have too much the sharp point like this, that can be, if we try to cut a material, the too much sharp point will be broken, right, in the process. So we should avoid the sharp point. So, and then that's why we need to have relief angle. So this is relief angle. So relief angle means that between the angle between the material called work and then the tool. So this is angle. So we should have certain relief angle. So generally, we recommend 10 to 15 degree angle. So this is example. So if the angle is too much, then the point too sharp toward edge, or is no clearance, that means we cannot cut the machine. So cut our material. So there's a rule. We have to appropriate angle. And then third one is rake. So in this example, there's a rake. Rake is also angle between the tool and then the tool surface. Because we have certain area like this, we need to have this area. So if you push or just rotate, then we cut this material and to fill off certain surface. So and then we took out the chips, but we need to have the space to allow chip goes out. So chip should go out by this way. But if we don't have this one, chip will be stuck, or chip will hit this tool. Then there will be create frictions. So friction create also heat. That means that will damage the material or the tool. So that's why we need to have certain space that took away the chips. So that's a rake. So angle that's away from the cutting tool. So that we just first need to produce chips. So yeah, this is important. So in this example, I explained about temperature. So if the angle, also the relief angle, is too much, there will be too much frictions. That means friction increase the temperature of tools and then the material. So if this increase of temperature can melt the material or chips or tools, so that could damage another damage. And then motion is also important. There are three basic motions: so cutting, feeding, and depth of cut. So in this example, this is the tool, right? And then this is the work. So to cut this machine, we need to have a motion. So let's say this is a chuck, and then chuck hold this work, and then this example. So the rotate the chuck with the work, then we just hold this the tool, then cut the example, cut the work. So that mean we have the cutting motion. This is cutting motion, and the second one with the feed motion. So uh, if we want to cut this area, we need to move this tool like this, back and forth. That is the feeding motion. And then third one is depth of cut. So how much we cut. So we need to define before we cut. So this is a half depth cut example. So we need to have three elements: cutting motion and feed motion and depth of cut. And then for the cutting motion, there are three types of motions. So first one is rotating motion. This is the rotate the work, the material. And then second was reciprocating one. That means move back and forth. So move back and forth. So this example is the jigsaw. And the third one is a linear motion. So move just one way. That is the example is bandsaw. Bandsaw also only move just one linear way. So there are three types of cutting motion. And next is separating machines. So there are there are many machines, types of machines, but this textbook we are going to learn six machines. So turning machine, drilling machine, a milling and sewing machine, and shaping, planing, grinding, sanding, and separating machines. Those are six machines that are used in our manufacturing industry. So first one is a turning machine. So this is the best example of turning machine. So in pottery, so the center is rotating, and then we can shape the material. That is the example of turning machine. So evolved from potter wheel and to unique operations. So straighting, turning, and face turning. So we saw this example in the lesson. So this tool cut this work by this one is a face turning, and then I'm sorry, this is a straight turning, and then this is a face turning. So cut this face, and then this is a straight the outside of the work. So this is turning machine that are we can see this turning machines in lesser machines. And second is drilling machine. So this is very a common machine in the manufacturing as well as technology classrooms. So that machine operates that reduce straight or round hole workpieces. In general, we use this drilling machine to make round hole. So there are many types of drilling machines, but the four types are general. So drilling is just make a hole like this, and then counter boring machine is making a little bit larger hole in the up and then make the general drilling machine. So this is the drill bit for counter boring. So this example can be if you use a nut and with the drill, we can use this counter boring machine. So this can be nut, and then this could be this screw. And then countersinking is a similar. So this is just regular drill, and then the top is like this shape. So we call this countersinking. This drill is used for special types of screw that has the butterfly shapes of the top. And then third one is reaming. Reaming means create hole, bigger hole. So initially we had like this smaller hole, but we wanna extend the hole. Then we can use the reaming drill bit to make larger the round hole. And the milling and sewing machines. So these are common in technology classrooms. So first one is circular saw and milling machines, and then this is depending on the motions. So first one is circular, and second is reciprocating up and down, and third one is one way, linear. So those are a common example. So first one is a circular saw or a table saw using this motion. And then the second one is jigsaw, example of jigsaw. So I found this example on YouTube.
Jigsaw uses a small blade and it cuts with an up and down
it's up and down, right?
motion. The thin size of the blades makes it easy to cut pretty tight radiuses, and
so in general, like jigsaw can cut the free shapes, so we can change these shapes. So, but this circular saw cannot change the direction because the saw is really big. So in general, the saw are 7-inch, 8-inch, or 10-inch, 12-inch. So we cannot change the cutting directions. But this jigsaw has very small width. This width is small, so we can change the direction. That's the advantage of jigsaw.
it's handy for cutting holes, something a bandsaw can't do. Its biggest limitation is that you can't cut really thick lumber. Usually this isn't much of an issue.
Yeah, can't cut thick lumber. So only you can like 1-inch or 2-inch lumber. So we cannot cut like 4 or 6-inch lumber. We cannot cut. So if we cut the 6 or 4 or 6-inch lumber, we need to use a bandsaw or the circular saw. So third type is a bandsaw. That's a linear movement.
A bandsaw is probably the most common tool for cutting curves in a woodworking shop, but it's expensive, it takes up space, and it has its limitations.
All right. So this is bandsaw. This is
it takes up
blade.
Space and
let me use my pen. So bandsaw has a in the inside the bandsaw there are two. This is a X. This is connected with a motor. So motor create the rotating forces, and also connect with a belt, another X, and then the blade is connected to this to the wheels, and then this is the blade. So this bandsaw only move to one side because that's rotating with the belt. So this is bandsaw. So bandsaw is much powerful than jigsaw, and also we can change the directions. This is bandsaw. So these are one example of milling and sewing machine. All right, so next is shaping and planing machines. So there are two types of machines, so metal shaper and metal planer. So let's just look at this example. First one is metal shaper. This machine is cutting this face. This is material. This is the machine. This is metal shaper, and then this is a metal planer. Yep. So how are they different? What are the differences between two machines? So shape, the movement are different. So this machine cut the material in the back and forth movement, reciprocating movements, motion, and then this one here, right, only cut the material in this one directional force. Yep. So those are differences. So shaping and planing machines are uh, shaping or planing actually. So the metal products. So those are shaping and planing machines. So, but nowadays there's not many shaping and planing machines because of most of manufacturing linked to the CNC machines. And then the grinding and abrasive machines. So this is the grinding machine.
To the chase.
So this is a grinder. So it's a special grinder. It has high hardness. So that is a sort of types of stone. And this is cutting this material. And this another example is disc sander. So this is wood sander. So this is sand and then material and this rotating. Cutting motion is rotating. So feeding motion is move the material close to the sand. So one thing I want to highlight this in the disc sander is if you want to if this is rotating like this way. So if you want to the grind this sand this wood, we should put this direction this way. So this is center of the wheel. This is rotating this way. So this force is coming the up to down way. So that's why we need to put our material in this direction, this area. So if we put material into this direction, then the force will be down to up. So that cause the fly away this machine, this material. So that's dangerous. So always we should put the material in the downward motion. All right, so and then the last one is shearing machine. So it's old machine, so it only cut a thin thin panel, a metal panel. So feeding motion is like this way, and then the cutting motion on this way. So that cut this metal sheet. So this is shearing machines. So I showed 6 general manufacturing machines that used in the separating processes. So this is summary. So you need to understand the differences of machining and shearing. So that is shearing is cutting the tool, but the machining is filling of the surface of material. This machining, and 3 essential elements of separating process was we need to have tool or cutting element, and then motion. This example is reciprocating motion. The motion will be circular or linear or reciprocating, and then supporter. So in this example, we use this vice to hold this material. Also, this machine itself hold this tool. So we also need to have supporting elements. And then we also look at these 6 basic machines. So turning machine, drilling machine, milling and sewing machines, and shaping and planing machines, and grinding and sanding machines, and lastly, steering machines. So I less highlights about these machines because these are industrial machines as well as rapidly changing the use of these machines. So as I mentioned, nowadays most of manufacturing processes are worked by CNC machines. So CNC machine, for example, CNC lather can do almost everything except a few functions. So yep, that's it. This is our first module.